Good day, everyone, and welcome to another edition of Combining Like Terms. That's right, today we're going to be combining like terms, or using properties of equality, to simplify some algebraic expressions. So without further ado, let's dive right into it. Boom! Our first algebraic expression has how many terms? Let's count up. 1, 2, 3 terms. But one of these terms is not like the other ones. That's right, this guy right here, it's different. And it's all by itself, so we don't really have to combine it with anything. But let's combine the things that are alike. For example, if I have 3 x's and I go to the store and get 4 more, how many x's do I now have? That's right, folks. I now have 7 x's increased by 2. And providing we've done this correctly, we have simplified this expression. We've gone from 3 terms to simply 2 terms, and that's just to double check our answers because I'm paranoid. And it looks like we did it correct. So we did it correctly, sorry. Let's move on to the next algebraic expression. Once again, remember terms are separated by addition signs and subtraction signs, which makes it really nice to count up. So we have 1, 2, 3 terms. But one of these terms is not like the other ones. This one right there. So we don't really have to do anything with that 9, but let's combine the things that are the same. So if I have 5 y's and I give 3 y's away, how many y's do I have? I have 3 y's. 3 y's increased by 9. And I trust that we have done it correctly, and of course we have. And now we're moving on. Oh, looky here. We have more than 3 terms this time. We have 1, 2, 3, 4, 5. Because remember, terms are separated with addition and subtraction signs, which really makes it handy when we're counting them up. Let's see if we can make this a little bit simpler. So first of all, let's highlight all the like terms, the x's, I should say. So if I have 3 x's and I get 5 more x's, how many x's do I have? That's right, folks. I now have 8 x's. So we represent that with an 8x. And now let's combine our y's. If I have 2 y's, but I subtract one of those y's, how many y's do I have? Well, now I have just 1 y. So we'll add 1 y there. And then, of course, this little 4 is all by itself. We can just tack that on. There's nothing to combine it with. And this is this expression simplified. And once again, 8x plus y plus 4 means we did it correctly. All right, let's move on to this next one. Back to the 3 terms, right? We've got 1, 2, 3. Oh, and we can sing the song. One of these terms is not like the other ones. That one right there. So all we have to do is combine our a's. If I have 6 a's and I get 2 more a's, how many a's do I have? I have 8 a's. I have a really nice looking report card decreased by 4. You know, there's something about saying decreased that just makes you sad. I guess unless you're on a diet. Yep, 8a minus 4. Boom. All right. Now, what if I got something like this? Well, once again, terms are separated by addition and subtraction signs. So this would be one term, and this would be another term. So we have 2 terms, but it kind of looks funky, so let's do something about that, shall we? Well, first of all, we can use the distributive property here. So if I got 2 times x, I can write that as 2x. Bring my plus sign down, and 2 times y gives me 2y. And now I can just add the 3x. And this looks a lot more manageable because I can highlight the things that are alike. If I have 2 x's and I get 3 more x's, I now have 5 x's increased by 2y. Boom. And with any luck, we did it correctly. Yes, 5x plus 2y. Da 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 da. Here's another example. Can you count how many terms there are? 1, 2, 3, 4, 5. We have 5 terms. So let's go ahead and combine the terms that are alike. I got a 6y right there, and I got a minus a y right there. So if I have 6 y's and I get rid of 1 y, I now have 5 y's. Okay, now I got x's. If I have 3 x's and I add another x, how many x's do I have? I now have 4 x's minus 2, because there's nothing to combine with that minus 2. And we have simplified this expression as well. What did I do wrong? 4x plus... Oh, okay, I figured it out. The nice thing about the commutative property of addition is it doesn't matter the way you order things. So we got 5y plus 4x is the same as 4x plus 5y. We can switch that around. Oh, threw me off for a second. And that, my friends, is why we think through what we're doing and we double check things. Okay, so we're in good shape. All is well. Okay, moving on to this next one. Once again, we have 1, 2, 3 terms. But one of these terms is not like the other ones. And of course, it's the one on the right, because I guess I have no imagination. So let's combine the ones that are alike. If I have 10 m's and I subtract 3 m's, how many m's do I have? 7 m's. Increased by 1, because there's nothing else to combine with that number. So, yes, we have in fact done this correctly. And to further our point from the last one, it would be accurate because of the commutative property of addition to also write it that way. That works too. 1 plus 7m is the same value as 7m plus 1. Okay, moving on. How about this one? Well, once again, we got the distributive property we can use, so let's go ahead and do that. We got 4 times x is going to be 4x. Increased by 2 times y, so 4 times 2, y is going to be 8y. Hope I'm not confusing anyone. And then we subtract the x and then add the 1. Okay, now let's highlight the terms that are alike. We have 4x's here, and we're getting rid of 1x right there. So 4x minus an x gives us 3x, increased by 8y because there's no other y's to combine it with, increased by 1 because there's nothing to combine with that 1. And with any luck, we have it written down correctly. Of course, the commutative property does apply here, but it looks like 3x plus 8y plus 1 is the correct simplification of this here algebraic expression. Okay, let's try another one. Now, you can pause the video. I know I'm talking a lot and try these on your own, but let's do another one. So we have 1, 2, 3 terms. One of these terms is not like the other one. It's that one. So we just need to combine our p's. If I have 4p and I get another p, I have 5p. Increased by 6. Boom! Just like that, we have combined like terms. And let's do this one. Aha! The distributive property. Well, let's count up our terms first. We got 1 term here, 1 term there, 2 terms. And let's distribute this 3. So 3 times x is going to be 3x, decreased by 3 times y is going to be 3y, increased by 2y. Okay. One of these terms is not like the other ones. That one right there. There's no other x's. So we're done with that. We can simply put 3x decreased by, maybe, decreased by 3y. But let's combine our y's. If I have 2 y's and I get rid of 3 of them y's, how many y's do I have left? Well, you said it. I'm down 1. So we are decreased. And that, in simplest terms, is going to be 3x decreased by y. Boom! And there she is, folks. And let's keep it going. I got all kinds of examples for you. Let's count up our terms here. We got 1 term, 2 terms, 3 terms, and 4 terms. Boom. Now let's combine like terms. Or first we got to do the distributive property. So 2 times 2x is going to give me 4x. And 2 times y is going to give me 2y. And then we add our x, we add our 3y, and we subtract our 4. Okay, now, I wonder how many terms we have now. We got 1, 2, 3, 4, 5. 5 terms. And let's go ahead and combine what we have. Okay, so, oops, I just used the eraser, my bad. I have 4 x's, and I add another x. How many x's do I have? I have 5 x's. Now, I have 3 y's. Sorry, 2 y's. My bad, I can't read. And then I add 3 more y's to that. I now have 5 y's. And then minus 4 is all by itself. Nothing to combine it with, so we just drop it down. And just like that, folks, we have simplified this expression. And just to make sure that we did it correctly, 5x increased by 5y decreased by 4 is in fact correct. But what do you do if you just have 2? We got 12w decreased by 5w. Well, that means, my friends, we got 7w. And just like that, we simplified a 2-term expression down to 1. All right, let's do 3 more and then call it. One of these terms is not like the other one. Yep, the -2 or the -2. But we do have a 9k decreased by a k, which gives us 8k. Hey, that's 8,000, man. Decreased by 2. And we have combined our like terms. Poof. And how about this one right here? Ooh, look at that. This one's alike and this one's alike, but that one's not alike. Let's combine the things that are alike. If I have 2 x's and I have 5 more x's, how many x's do I have? I have 7 x's increased by 7 because there is nothing else to combine it with. Boom! And we have combined like terms. And one final one for the grand finale. Boom! This guy right here. We have 1, 2, 3, 4, 5 terms. Let's see if we can simplify this a bit. Okay. If I have 4 x's and I add another x, I know that I have 5 x's. If I have 7 of something and I get rid of 3 of that thing, how much do I have left? Well, that means that I now have 4 of whatever that thing is. And then there's nothing to combine with the 2y, so I can simply add 2y. Now, I'm sure you've noticed that the commutative property does apply here because we're adding things, so order doesn't really matter as far as how we add these things. So 5x plus 4 plus 2y is going to be the same as 5x plus 2y plus 4. Thank you, the commutative property. And with that, here's a smiley face. I do hope that was helpful to you. I'm going to sign off now. Y'all have a good one, and best of luck.